Hello everyone, welcome to our channel Wisdom. So in this video we will be building a Flask web app, and this video is basically a continuation of our NLP project series. This classification of patient's condition, and in this video we will be uh, building a Flask web app in which we will classify patient's condition based on drug reviews, and further will also recommend top rated drugs based on the medical condition. So this will be a complete package for a healthcare project. In this, you have to just paste the reviews of the patients which may be suffering from any two, three types of diseases on which our model is trained. And then our model will give two predictions. First is the patient's condition, and second is the top three rated drugs. So before moving towards our video and explanation of full project, uh, I request you, if you like our video and if you want to get notified for our upcoming videos, then please subscribe our channel so that you will be notified when we upload our new project videos. So let's start today's video. Hello everyone, welcome to our channel Wisdom ML. So in this video, we will be building a Flask web app, and this part of the video is the continuation of our classification of patient condition series, in which we have built a machine learning model with the help of natural language processing techniques. And basically in this video we'll be talking how we saved our model, how we have uh, used and integrated that model into Flask web app. And this Flask web app is basically gives you two predictions. First, it will be giving you patient's condition based on the drug reviews of the patients, and the second, it will recommend top three drugs based on the ratings given by different patients in the drug reviews dataset. So this will be a very interesting video for you, and if you want to use it as your project, portfolio project, so that will be a very interesting video. So before moving towards the video, I'll request you, if you really like our video, then please like our video and subscribe our channel so that whenever we upload new video or project based video, so it will give you notification on email. So let's start today's video. So I will first give you the basic overview of this project. So in this project, basically we have used drug reviews dataset, and in the previous video we have built drug patient condition classification model. So if you have not seen our video of machine learning model building part, so if you have not seen our previous video of machine learning model building part using drug reviews dataset, then I recommend to watch that video first and then see this video. So firstly, we have used our drug reviews dataset, which is basically labeled on UCIML repository website, where we have drug reviews, ratings, and uh, timestamp given on which that reviews is given, and the medical conditions and the particular drug against which the reviews and ratings are given. So in the first step, we have actually pre-processed our data because it consists of lots of noise. So we have removed the noise, prepared it for machine learning model building. So in this step, we have pre-processed our data because the data set consists of lots of noise. So we have removed noise, processed it, and prepared it for building our machine learning model. In the next step, we have done train test splitting, in which we have divided our training and testing, in which we have divided our data set into training and test set, so that we can train our model on training set and test it on test set, which is completely unseen to the model. And in this, we have used 80:20 ratio, 80% used for training data and 20% for testing or evaluating our model. Next part is very important because uh, any machine learning model only understand numeric data. So we have to convert our textual reviews into vectorized format, that is numerical format, so that machine learning can understand into numerical format. Next, we have built our machine learning model. So in this, we have used a couple of models which usually perform better in textual data. So in this, we have used a passive aggressive classifier and Gaussian naive Bayes. And after building our model and evaluating on test set, we have saved our model. Okay, so that using .pkl extension, and we have used that pkl files for building our Flask web app, so that we can integrate those machine learning model files and vectorization files into our class web, so that whenever any user enters any review, then we can load first our model, our vectorizer, which vectorizer will convert the textual data into vectorized format. And after converting into vectorized format, we'll be using our machine learning model for doing the prediction. So, so what is the output of this Flask? So this Flask web app will output you medical conditions, that is high blood pressure, diabetes, depression, in birth control. And apart from that, it will also tell you top 3 drugs. Now the question is, we have built only classification model based on the previous data set. How this recommendation will come? So basically, in for recommending top 3 drugs, we have used drug reviews data set only. And how we are doing it? So first of all, we are sorting our data set based on the ratings and useful counts. So useful counts are something when user gives uh, thumbs up to the reviews and if they found that review useful. So we'll be using these two parameters, ratings and useful reviews, for extracting our top drugs based on the condition. So first of all, we are sorting our data set based on rating and useful count, and then we are passing it the medical conditions. We are filtering it using medical condition and extracting top 3 drugs based on medical conditions and higher rating and useful count. So let's move to the Jupyter notebook, in which in our previous video, in which in our previous video we have built our machine learning model. So let me just zoom a bit that you can see better. So you can see that this is our libraries we have used. So what we're doing basically, in our previous video, I have shown you how we have built our machine learning model using TF-IDF vectorizer. So we have convert the training data into TF-IDF vectorizer and transform our test data also. And then we have evaluated both our machine learning models. So first we have used bigrams, and second we have tried with trigrams. And we found that with trigrams we have greater accuracy. So further we have also extracted most important features by passing vectorizer, machine learning model, and the condition. So now we'll move towards the part where we are actually saving. So here, as you can see, we are using joblib library for dumping our vectorizer and machine learning model. So our machine learning model is passive aggressive classifier based on TF-IDF. So that's why we are passing it as PASS-TF. Whereas we have used trigrams vectorizer because they have performed better. So like that, we can dump our both vectorizer and model files. So what it will do, it will deserialize your models so that you can reuse it on other machines or in web app, web application, mobile application, anywhere you can use it. So now comes the best part, that is how we have done the recommendation. So what we are doing it basically for predicting, we are basically uh, we are passing some sentences, sample sentences. So first one, as you can see, it is high blood pressure, then we have depression, then we have diabetes. So what we are doing, we are loading our vectorizer and transform these sentences which are in list form. Okay, so we are transforming it into vectorized format, and then we are passing this vectorizer into predict function. So actually, we are using our machine learning model for predicting these vectorized data. And here we are actually iterating through the sentences in our predictions. So if our label is high blood pressure, so we are setting it as target high blood pressure, and we are using this function top drugs extractor, where we are passing the label, that is the condition, and this will gives us a top three drugs based on the ranking and the ratings of the patients. So if you see the output, it is something like this. So we have text, and then we have condition, and then we have top three suggested drugs based on this condition, high blood pressure. That is losartan, aldacan, and spironolactone. So this is something which we have developed. So now I quickly show our web application. So this is our web app, class-based web app, which we have created. So let me log in into it. So in this, we are using admin@gmail.com and admin as our password for logging in. Now we have to paste, the user have to paste the reviews in this text box. So let me copy and paste this. And now we have to do the prediction. So it will take time because it will do some TF vectorization. And you can see this is our original review, so that we can understand what was the review. And then you can see this is the predicted medical condition, that is depression. Now if we see, let me zoom a bit. If we see the review, so this is the third medicine I have tried for anxiety and mild depression. So it is related to depression, that is for sure. And that's why the prediction is right. And based on the medical condition, we have extracted top three rated and useful count based drugs, which are mostly recommended or prescribed by doctors in depression. So this is our web app. So you can understand how useful this web app. We have to just pass the review, the medical condition of the description of the medical condition of the patient, and we will receive the medical condition as the prediction and the top three recommended drugs. So let's move towards the code, how we have built this. Okay. So for building this, what we have done basically, so we have let me show you the physical format of this web app. So this is our drug prediction web app, and as you can see, we have data, we have model, we have static, we have templates. So template static is our basic Flask structure and app. So we are basically using basic Flask structure, in which we have a static, and static contains static files which give design and fonts to the website. So we are using CSS for giving basic background design layout to the website, to the web app. Fonts we are using for certain fonts. Images we are using for loading certain images that you have seen in the login page. And JS we are using JavaScript for certain things. Now, as we can see, another folder we have templates. So, as I told you, templates contain all the um, HTML files which are actually rendered on the web app. So, basically, login is our login page. Okay, index is our page which is actually used. Uh, Not index. Home is actually used for entering the text, and actual prediction we are getting in the predict. So this is the overall structure of our web app, and most importantly, we have one requirements files also, which is in .txt format, and this is required if we have to create any environment, or if we have to create, let's say, Docker file where we have to create Dockerized container. So we have to mention our requirements. So we have actually used Flask, Pandas, Unicorn server, scikit-learn, NLTK, and Beautiful Soft 4. So these are the basic requirements of our web app. So for building any web, what we have to do first, we have to create. First, we have to create. Let me go to, yeah. So I have to delete this. And let me close this app. Okay, let me close. Now we have to open our terminal, and we have to create one environment, virtual environment. So how we will create, basically we have to use one command, conda create -n, and we have to give our environment name. So in this case I am giving drug env, and then we have to pass the Python version. So in this case we are using Python 3.8. Once you click on enter, it will create your conda environment, and will ask you certain questions like these wheels it has to install. So we will be entering y here, and it will install all the dependencies for creating any conda environment. So this conda environment will help us to run our Flask web app without conflicting with our base environment, which we have as an Anaconda environment system. So now we have to first activate it. So Honda activate, and the environment name drug env. So as you can see, this is activated. Now what we'll do, we have to install our dependencies. How we will do that? We will enter pip install -r requirements .txt, and it will install all the libraries which are required for running this web app. So as you can see, it will install everything with no exceptions and warnings till so far. So all the dependencies are installed. So let me start the app. So for starting the app, we have to write Python app dot. So it will run the app on our local host. So as you can see, we have mentioned if name equal to main. So here we have to mention where we want to run our. So we have mentioned host as localhost port 8080, and debug is equal to true, so that if any error comes while running the app, it will give you messages and proper error messages in Python. So for running, you have to just give control click, and it will load. Let me. Yeah. So here we have to mention admin @gmail.com. Here we have to pass admin, and the app will open. So let me go to the code, how we have built this. So I'll quickly walk over to the code of this app.py file, and this is the main heart of this web. Other things like CSS and all, I will share with you so that you can use as it is and import it, and the design will be automatically imported once you use the exact structure which I have. But understanding the working of Python file, that is this app.py. It is very essential. So here we are importing all our necessary packages which are used in this app. Next, we are passing our path. So model path, which is our pass model.pkl file. Then we have tokenizer path, which is our TF-IDF vectorizer, which is the vectorizer in .pkl format, which we have saved in the Jupyter notebook. And then we have a data path. So this drugs reviews data set in CSV format, which we have saved in the data folder. And in under data folder, we have this drug reviews data set. So this we have used for extracting the top 3 important drugs, top 3 rated drugs based on the medical condition. So these 3 files we will be using. So for using it, we have to load our vectorizer. So we can load it using joblib.load, and we have to pass the tokenizer path. Similarly, for model, we have to pass the model path. Then we are doing certain pre-processing on the entered text. That is, we have to remove all the stop words. We have to lematize into all the words into their base forms. Okay, and so these are the 2 important libraries for pre-processing. And if I go to here, so this is our clean text function. What it will do, it will delete all the HTML. So if you paste any HTML text into it, it will remove that. Then it will, what it will do, it will only retain the letter or alphabets, and it will remove all the special characters, numeric digits, everything which have no value in terms of context. Then we'll lowercasing all the text, okay, so that every word will be in universal form. Then we are filtering all the words which are not in stop words. So basically, we are removing all the stop words from our all the words in the sentence. Then we are basically lemmatizing all the words into their base format. And after that, we are joining all the words into one string, or you can say sentence. So this is our main function for cleaning task. And so what we're doing, so these are our base functions. Slash means it will open login.html. Slash logout will clear your session and redirect to login page. Flat index routing means, and if it is in user session, means if you are logged in, then it will render home.html page. So what this home.html is basically this page. Okay, after login validation, this home.html page will open where you have to enter the text. So now the next function is login validation. As you can see here, we are receiving username and password from the user and assigning the session of user ID as username and session domain as is the password. Okay, so we can remove this. There is no requirement of this. So only user ID will be enough. So session user ID we are using, and we are checking in a very static condition, that is username is equal to admin Gmail or password is equal to admin. If this is the case, then we are rendering home.html. Here you can do your customization, or you can use any database, MySQL, SQL Server for doing the validation by creating login table. Okay. Now let's go to next part. So once you have entered the text, right? Once you have entered the text, let me again enter the text. So how it is functioning. So if we enter the text in this text box, okay. So let me go to this home.html file so that you can understand better. So this is our home.html file. And if we go to the text box, so this is our text box. Okay. You can see intermedical issue for getting drug recommendation. And this is our text area where user have to enter the text. So this whole thing is within the form tab. And if we want to submit anything, we have to place that segment of code or that element into the form tag, within the form tag. Because once we click on submit button within the form tag, it will do post function, and it will post all the values which you have entered in the input fields to the server. And the best part is we have to supply two things here. Method is equal to post and action is equal to slash predict. So here you have to give the actual route where you will be handling these entered values, or you will be using these values for prediction. So slash predict, you can see if you go here. So this is our function, routed function slash predict, where we are also mentioned method is equal to get post. Okay. So that's why we are we are checking whether request dot method is post or not. If it is post, we are receiving the text box value in raw text, and we are checking if it is not a blank value. If it is not a blank value, we are cleaning the text by passing this raw text into the clean text function, which I have shown to you. It will give you a clean text, okay, by removing stop word, lemmatizing, lowercasing, and retaining only alphabets. Then we have to convert it into a list format, because our vectorizer or model will only receive iterables. Okay, so we are converting it into a list by placing square brackets, and then we are using our vectorizer. So in vectorizer, what we have to do, which we have loaded previously, so we have to pass vectorizer dot transform, and we have to pass the actual text list of text. So in this case, we will be getting one text at a time. So no issue, that will be converted into list and passed into it. Now the prediction. So whatever vectorizer we get in the form of iterable, we'll passing the vectorizer in the model.predict function, and then we'll receive the actual prediction, which will be in textual form. That is high blood pressure, diabetes, and depression. So for that, we'll receive it by passing as 0. Okay. So we got our predicted condition. That is the best part. Now we are reading our data. That is drug reviews data set, because now we have to recommend top 3 drugs based on rating and useful count. So for that, we are reading our data set, and we have to pass two things into it as a parameter in this function, top drugs extractor. First is the predicted condition, which is in text format, and second is the data frame. So if we go to top drugs extractor, which is this, so here we are receiving the condition and the data. And what we are doing, first of all, we are filtering our data set, filtering and sorting our data set based on the rating and useful count. First of all, we are subsetting our data set by rating greater equal to 9 and useful count greater equal to 100. And after that, we are sorting it by rating and then useful count. And by setting ascending is equal to false means in descending order, so that higher rating and higher useful count will come first. And once we get this data frame, we will pass condition into it, our predicted condition. So that second level of filtering will happen, and then we will be extracting the actual drug names. So once we get the drug name, we will then take the head of it, so that we can get the top 3 drugs, and then we are converting into a list form and returning this drug list. So you can see we are returning drug list. Now if we go to predict function, so basically this top drugs contains nothing but a list. You can see that. So now after prediction, we are rendering predict.html page, and here we are passing two things, that is raw text, because we have to show the entered text in the output as well. Then we are passing result as our predicted condition, in the result variable, and in the top drugs variable we are passing our extracted list of top 3 drugs. Now if we go to our home predict.html, so we can see that this is our one section where we are basically passing raw text, which is the entered text. Second div is regarding predicted medical condition. So here we are passing our result. And the third is our top 3 drugs. So for showing top 3 drugs, we have to iterate on our top drugs list, and we have to pass it by using for loop and for top drug and top drugs, and we are putting top drug one by one. So for giving a look and feel to this is the round shaped button like background. So here we have used one CSS round one. So if we go to our main page, that is in this page, as you can see, we are extending our home.html. So everything which is in our home.html, that is navigation, background, color, and everything we are extending from home.html. And home.html, we have passed one a special CSS class that is round one, that is this within paragraph tag. And here we are giving the border radius, padding, text alignment center, color black, and background this color, which is the color of this. So this is the expression of our web app, whole web app. The whole code is available on our GitHub. You can download it and you can freely use it, no issues. And you can use it in your portfolio projects by customizing and adding more features into it by extending into sentiment analysis also. So I hope you like this video, and I hope you learned something new in this video. So let's meet on our next project video, and till then, bye bye, have a great day.